Am I mic'd up? Okay, great. And I'm going to stand behind here so I can advance slides. So I became a Christian at the age 39. I'm 67. I'm too tired right now to do the math, but you can. So, and physics was a big piece of that. And about when I was 40, I started teaching a class. It turned into a 6-hour class. Kind of the stuff that I learned that really messed me up as an agnostic. And that led me to the foot of the cross. So what you're going to see here is from my 6-hour class. And it's just a little piece, And my book came out of that 6-hour class. So almost everything that's in the class is in the book. But I didn't cover about a third of it last time, just to let you know. But there are a big section of the book is about light. So from the class, this is the agenda of the entire class. They talk about the size of creation, which I probably did a little bit last time. The bizarre nature of light, that's what we're going to be talking about tonight. And then physical reality is pretty bizarre, actually. And then there's some other weird things. And then I end the 6-hour class with kind of what was my bottom line from all this strange stuff. So tonight we're going to talk about the bizarre nature of light. And when I was here, is there anybody that was not here when I spoke Sunday morning? Okay, all right. So I'll give a quick review of what I talked about there. But some of that was about light. But there are 5 characteristics of light that it hit me not right away, maybe 15 years ago. It's like, this is like God. These 5 characteristics of light, that's like 5 characteristics of God. And there's many more characteristics of God, but it's like, it was interesting that the parallels. So the first is that light appears to travel the same speed regardless of the speed of the observer. Only light does this, and I'm not going to get into it. I talked about it when I was here on a Sunday, but this is the theory of relativity. And it turns out that light is the only kind of standard like this, that it never changes regardless of what we're doing. The speed of it, if we come close to that speed of it, it still measures the exact same speed, even though we're almost going the same speed. It's the only thing that does that. It's an unchanging standard. So that kind of reminds me of God. And again, that goes back to Einstein's theory of relativity, which all physicists that I've ever spoken with and have read about say, yeah, that's proven. I'm not sure what you can do to prove these things. And then secondly, the way that works is that it turns out that time really does not have any meaning to light. So a beam of light comes to our eye from a million light years away, a million years to get to our eye. To it, because it travels the speed of light, there's no such thing as time. And so it touched everything at the same time. And it's everywhere at the same time. It sounds like God. It's kind of like omnipresence. So I think I talked about those 2 things there. Now we're going to get into it. That's bizarre enough. That's pretty bizarre. But what I'm about to share with you, when I first started teaching this, I'd say, I don't smoke dope. It's gonna feel like I'm some weirdo. This is a bunch of nerds, right? The physicists that discover these things. These aren't a bunch of hippies. And so anyway, what I'm going to share is going to be maybe unsettling for you. It's still unsettling for me, and I'm so many years into wrestling with it. And much of the Bible's unsettling too. How God really is, the mystery of God, and God's ways not being so. So light exhibits a dual nature. At the same time, it's a wave, and I'm going to describe waves a little bit more in a minute. But it's also a particle, and those are 2 opposite things. But how can it be 2 opposites at the same time? And so I might ask you, well, is God 3 or is God 1? It's like, yeah, somehow this triune being is 3 and 1. And And so there's some parallels there. There's some things in the Bible that describe God that have parallels in light, that it's these two things at the same time, but they're opposites. Light behaves differently depending on how we choose to observe it. And that may not sound really freaky yet, but when I go through the experiments, you'll go, know what we're doing and act differently. It's like, no, somehow it knows what we're doing. Almost like God. You can't trick it. It knows if we're watching or not. And so you could call that omniscience, if you expand it a little bit to what God knows all. You can't hide. And then the last thing that I feel is, there might be many other things, but that I feel similar to God is that light seems to be able to predict how we will observe it and then act accordingly. Yeah, so what I'm saying is that light knows if we're going to watch. And if it watches, it acts like a particle. If we don't watch, it acts like a wave. I'm going to describe this in a moment. And it also knows what we will do. Now again, time doesn't have any meaning to light. So time physicists would say, time's kind of our issue. And some physicists would say, we think somehow time can go back. We just don't understand it. And there's some biblical things about time also, the Alpha and the Omega. And so anyway, these are the 5 things that over tonight and a week from tonight, I'm hoping I'll be able to go. Now you know what I was talking about. Okay. So light is very mysterious. And so I'm just going to fly through this. I didn't have slides when they came on that Sunday, I don't think. I just kind of described it with my hands. And so these slides are sort of like what I described. But if you had 2 cars going, one's 80, going 80, and the other 50, you'd think the relative difference is 30. But that was light. The relative difference, it's always the same, regardless. So I'm gonna, if I'm running on a train 15 miles an hour, but it's going 80, it's like, so how fast am I going? You have to compare it to something. Compared to the train, I'm going 15. Compared to the cornfield, I'm going negative 65. And so it's relative. But light's not that way. Everything is relative as far as speed, except light. And again, I'm not going to go into that. If you become really intrigued and you really want to know more, you can either buy my book or you can ask me. But probably be faster for you because I love to talk about this stuff. So I have my book. So I'm just going to move on from this because I've already spoken about this. The implications of relativity, the implications of this theory that all physicists I've ever spoken with or read go, yeah, it's true, is that time slows down for things that travel near the speed of light. So you take 2 twins, you put one, and they're 40 years old, you put one in a super fast spaceship, the other stays on the tarmac, and goes home and just lives, and 20 years later comes back. The traveling twin is only 2 years old, depending on how fast the spaceship's going. So they've done some experiments like that with super accurate clocks. And sure enough, the formula would predict that the one traveling as fast as we could get it to go is, half a second younger than the one that stayed, type of thing. So we just really believe this is true. There's other experiments physicists have been able to do, but as you approach the speed of light, time slows down. If you go the speed of light, time has no meaning. So I've already talked about that. Yeah, I'm gonna forget that one. Schrodinger's, the first book that got me into this stuff was called In Search of Schrodinger's Cat. And Schrodinger's cat is a famous thought experiment between Erwin Schrodinger and Einstein. And but I'm not going to get into that. There's kids in the audience. Scripture is just full of references to God. I'll just share this one. When Jesus spoke again to the people, he said, I am the light of the world. Whoever follows me will never walk in darkness, but will have the light of life. And when we read that, we go, yeah, I mean, it's because we can see with light. Light shines. But then I was reading all these things about light. And then so many hymns, I'm the one true light and the pure light. And I just started, kind of going a little wacko. And in a good way. And maybe this metaphor is so much richer than what we thought Jesus was talking about. And maybe read that way too, but maybe living water has those kind of mysteries as well. So that's what I've covered in the past. Any quick questions before I take us into what are waves and what are particles? So when you see a wave and you see it moving toward the shore, what are you watching? Are there water particles moving toward the shore? Or let me ask maybe a better one. I'm a spark. Any go greens? Okay, so we're going to use. So at Spartan Stadium, not the big house, but at Spartan Stadium, when the wave is going around, what is it you're watching? There's no people going around. Anybody want to take a guess? What is it you're watching when you watch the wave at Sports Stadium? Yeah, what's actually happening is people staying with this. There's a particle of water just sitting there doing nothing, and all of a sudden something happens, and it goes up, and it goes down, and it goes like that, and it settles down again. But it didn't really go toward the shore. So what would you describe a wave? What is a wave? Anybody?
Reaction to outside force.
It's reactions to an outside force. What are you watching? Motion?
You see, right?
Continuous motion, but again, the motion is actually people standing up and down. You're watching something. And so it's synchronized motion. Like a marquee, but some of us are old enough to remember, right? The theaters, they'd have marquees. It looks like the lights are going around. There's just lights blinking at just the right time. It's very organized, synchronized. And so waves are energy that's synchronized and orderly. But it's not a thing that you're watching or on the stage. You're not watching a thing. You're watching synchronicity, or you're watching, some agreed upon, when will we do a burst of energy? And it'll look like something. So waves are kind of weird when you really stop and think about it. So when two waves interfere with each other, so if I have a pond in front of me and Doyle throws a stone there at the same time I throw a stone over there, the ripples are going to come together. Can you guess what happens when they come together? In the back, you had your lips moving, so. They become one sort of kind, they become one wave. But there's something else about that one wave that's unique. So, see if I can do this. Pardon? So no, well, yes, no. So I'm going to try to do a hula dance here now. So imagine these two waves are coming together, right? And if they meet peak to peak, all that water has to go up here. So it just became double. But if they meet, oh boy, here we go. If they meet like this, it's just flat. It's like there was no wave there at all. So that's called interference. And this is one of the ways that we know what's going on when we're studying light or some other things. Like, is it a wave or is it a particle? And if it's a wave, you see this interference thing. So I'm going to show you an example of what that looks like. So this is when the peaks come together. That's called constructive interference, and it doubles the size of the wave, which is what can happen when you get a rogue wave on the ocean or something like that. It's when all these waves came together and it just happened, their peaks just happen to come at the same time. Or they can just cancel each other out. So that's destructive interference. So this is kind of what it looks like with light. So if you have two slits, see the two black slits in the middle blue bar there? So imagine that's a wall. And you have two slits in the wall, and you've got a light source at the far blue side. And so if light is a wave, you're going to see those waves come through the two slits, just like the two pebbles. You're going to see this interference pattern. You've got extra bright and also no light at all. And so on the green, you see very bright in the middle, then a dark spot, then bright, then dark. That's an interference pattern. So that tells you, oh, what we're looking at coming through those slits is a wave. By the way, if I've lost you, it's okay. This isn't super important, but if you don't understand it, it might make it richer when I share what happens. Now, if you did that with particles, let's say golf balls, if light is like these little packets, these little particles, then it would go through either slot A or slot B. You know, by the way, a bunch of them would just fall down because they didn't hit. And you'd end up with spots in the back wall where the golf ball. If that's light, you'd have two bright spots, but not bright, dark, sort of bright, dark, sort of bright, dark. That would be interference. So if light is a particle, you'd see this. If light is a wave, you'd see that interference pattern. Anybody want to ask a question before I lost some of you? Unfortunately, it's just some of this stuff is really kind of tricky to get your head around. And if you're reading a book, you can just stop and kind of, okay, what the heck? And yeah, this picture's in the book and things like that. So anyway, I'll keep moving on. One of the most difficult things I love to teach, I teach leadership stuff, and often people are really engaged with me. But when I teach this stuff, it's often deer in the headlights, because either you're not understanding what I'm saying, or you are understanding what I'm saying. Either way, it could be deer in the headlights, because it's like that can't be true. Okay, and we haven't really gotten that part yet. So if we observe individual photons, so turns out you get light down into the smallest packet possible. That's called a photon. You cannot have a half a photon. It's the smallest packet of light. And these are super high-tech labs where they can get one packet of light and send it through the experiment where there's slit A and slit B. And so there's just one going up there. And if light is a wave, then we'll see it interfere with itself. We send one and another and another and another, but always separate. And then a pattern starts to appear on the back wall. And if it's an interference, we know, oh, those were waves, because that one thing had to go through both slits at the same time. Okay? So if we observe the individual photons of light in the two-slit experiment, each one behaves like it's a particle. And so that's the pattern we get. When we watch, which slit did it go through? It goes, oh, they're watching me. Okay, I'm going to act like a particle. They'll be able to tell which slit I went through, and I'm going to leave a bright dot on the back wall. Some of you already know about what I'm about to share. However, if we don't watch it, they just send them through one at a time. Let's go out to lunch, and then come back and see what ends up on the back wall. It's like, oh, they're not watching me. So this one little, you think of as a particle of light, all of a sudden is like a wave, and it can go through both, interfere with itself, end up on the back wall when you do 1,000 of them, to where it goes, oh, there was an interference pattern. And so it's weird enough that light can be two opposites, kind of at the same time. It's extra weird that if we're watching it, it makes a difference. We've tried to trick it and say, well, what if there's a way to watch it where there's no way it could know we're watching it? It always knows if we know which slit it went through. And if we can't know which slit it went through, then it goes through both. because, at least my understanding of it is, if I take 1,000 of them, but just one at a time, after it's hit, send another one. After it's hit the back wall, send another one. And there's ways to watch, and then unfortunately, again, this is so tiny, 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 and you don't just sit there and watch it because you can't really see one photon. So you have to have some kind of mechanism to measure, did it go through this one or this one? So when I say watch it, that's what I mean. And when we keep that mechanism off, then it acts like a wave and goes through both slits at the same time. In a moment, I'm going to show a video. But first, I wanted to describe it. One of the things I know is difficult things, you try to teach them in more than one way. But so, does that sound like proof to you that when they do the experiment and they know which slit it went through, it acts like. And when you turn the mechanism off, so we don't know which slit it went through, does that answer your question?
Yeah, how do you know? That's the question. If you're not watching it, is there a way to measure what it did when you come back? Do it so that they
Yeah, yeah. So now I understand your question. So on the back wall is a photosensitive film. And so each photon will leave a mark as to where it went. And so when you come back, so it leaves this history of what happened. And so on the left, you see the blue stripes. It leaves 2 bright spots. If we had the mechanism on that could tell us which slit it went through. But when we turn that off, then you end up with what you see on the right, green, where it's got the interference pattern. So that's the evidence that it leaves. We can't tell from each one, but the collection of 1,000 or 1,000,000 or however many they send through. So, thanks, great question. Okay. So light exhibits a dual paradoxical behavior, meaning it's like 2 opposites. You can't be a particle and a wave. If there was a particle thing going on in the Spartan Stadium, you'd see a person going around. That would be more like particle physics. But if it's a wave, you just see this kind of mysterious energy where all of a sudden it affects, in this case, people, but in other cases, water molecules go up and down like that and just settle back down. And you go, oh, well, but it's when you look at all of them, you go, oh my goodness, look at what happened. There was a synchronicity of energy that went by. So it exhibits this behavior. So I want to do a quick little experiment with you. What is that up there? Yeah, it's a cube. Okay. I want to know which face of that cube is closer to you. And I'm going to see if maybe we can get it. Maybe. Did I just lose? Okay. So you see one that's grayer and you see one that's bluer. The grayer one is further up and to the right. The bluer one is further down to the left. I want to know which one is closer to you. Raise your hand if the bluer one is closer to you. Okay. Okay. Ooh. I'm going to get to you in a moment. Raise your hand if the grayer one is closer to your face. Okay. And what did you just say?
Mine looks out there at it, and then all of a sudden.
Yeah, that's kind of freaky, right? This is sort of like you've seen these things where there's an old woman and a young woman. It just depends on how you look at it. So they're both there. And so it's like there's 2 cubes up there, but they're both there at the same time. So somehow it's like this with lights and plates and all that way. Now here's a little side note, a little how to get along with people. Nothing to do with physics, more to have to do with leadership. It's impossible to see both of them. You can toggle back and forth. And by the way, maybe some of you haven't been able to do that yet. When I first showed this to my wife, I scribbled it on a napkin. We were dinner, and I'd read this in a book, and I said, "Do you see both cubes?" She goes, "Yeah." And inside I'm going, "Yes." And I said, "You sure?" She goes, "Yeah, I can see both." Then we started eating or something like that, and then she went, "Oh." And then now you see both, because there's this like, oh, it's so clear. But you can't see both at the same time. And so if you see the world like a blue cube, and I see the world like a gray cube, there's no way I'll ever be able to see your cube unless I let go of mine. So that's an interesting kind of, how do we get along together? And it doesn't mean I end up believing your cube's the right cube, but maybe some things, maybe light's a wave and it's a particle. By the way, for longtime physicists, in probably around 1900, they were fighting because they had proof that it was a wave. They'd done all these experiments. It's a wave, clearly. Others had done experiments. It's a particle, clearly. And instead of forming two denominations, somehow they figured, yeah, somehow it's both. We don't understand. We still don't understand. Somehow it's both. And I think that relates to God.
Out of curiosity, are there any theories that they've come up with that make sense as to why it changes?
Not that I've read or heard. We just know that it does. And I would say the same thing about some things in the Bible. Do we know why? It's like how God is. So, okay. 7:33. You want me to go till 7:45? Of course, time really has no meaning. So.
If you're right.
If I'm like, I'm not that like.
Move over to the right just a little bit.
Are there some dualities in the Bible that you can think of? Some paradoxes? Yeah. I'm strong when I'm weak. I think you can pick a bunch of them out of there. There's this whole saved by grace, and yet saved by faith, I mean. But faith is dead if there's no works. It's like, so somehow it's got to be, so anyway. And that was a problem for me as an engineer. I was an engineer. It's like, it's conflicting stuff. How can you believe this? Because it doesn't even agree with itself. And then I found out, well, neither does physics. It's like, oh, man. So, there's also duality in life. I'm not going to go much deeper into that. So, yeah, so here's some dualities. It's probably too small for you to see it, but this is John, 1 John. No, sorry, this is John 1:14. John. Yeah. So, in the beginning was the Word, and the Word was with God, and the Word was God. Well, the Word was with God. The Word was God. And so you can go through, there's a bunch of other sort of, when I was this linear thinking engineer, it's like, yeah, this is crazy stuff. But then my beloved science took me into a world of the same kind of things. So, okay. Yeah, so then there's this piece about, so it's got this dual nature, but then there's this piece about it somehow knows. And physicists don't like it when I use that word. They go, what word should I use? And then they go into physics talk. It's like, no one understands those words. So I just want you to know, it's like, I don't know if it knows. Right? I'm not saying it has a brain. I'm not saying it has, I don't know. And what I came to is like, every atom is God. And so I'm just going to use the word it knows, or somehow it's aware. So now I'm going to show you, there's videos out like cartoon called Dr. Quantum. And Dr. Quantum does a great job at describing these weird things. But Dr. Quantum comes to different conclusions about what it means than I do. So if you go out there and start looking at Dr. Quantum, just know he doesn't believe in Christ. He's more of a Buddhist and kind of a, it's like, okay, well, we all have to make sense of the world. But when I was going through this, not as a Christ believer and follower, the Holy Spirit was really messing with me. And in a bunch of my books, it would say, you'd say, well, how can this be? You'd say, well, if there was a God, yeah. So anyway, so here's, hopefully this video comes out pretty well. Probably 4 minutes. It's actually got sound. Maybe we'll get the sound. In the meantime, maybe I'll talk about what it's. So he's talking. So yeah. So these are electrons. Let me say something about that. This is not light. This is electrons. And electrons basically determine all chemistry, which determines all physical properties. And so electrons do the same thing I was describing to you about. So a wave going through a single slit is going to hit the back wall with a bright spot. See it here in a moment. So
Shows that intensity. This is similar to the line the marbles make. When we add the second slit, something weird. It's the infamous double slit experiment. To understand this experiment, we first need to see how particles, or little balls of matter, act. If we randomly shoot a small object, say a marble, at the screen, we see a pattern on the
electrons do have mass. They are a particle.
Now, if we add a second slit, we would expect to see a second band duplicated to the right. Now, let's look at waves. The waves hit the slit and radiate out, striking the back wall with the most intensity directly in line with the slit. The line of brightness on the back screen shows that intensity. This is similar to the line the marbles make. But when we add the second slit, something different happens. If the top of one wave meets the bottom of another wave, they cancel each other out. So now there is an interference pattern on the back wall. Places where the two tops meet are the highest intensity.
That's an interference pattern. Proof.
They cancel.
Evidence that it was a wave.
So, when we throw things that has matter through two slits, we get this. Two bands of hits. And with waves, we get an interference pattern of bands. Good. So far. Now, let's go quantum. An electron is a tiny, tiny bit of matter, like a tiny marble. Let's fire a stream through one slit. It behaves just like a marble, single band. So, if we shoot these tiny bits through two slits, we should get, like the marbles, two bands. What? An interference pattern. We fire electrons, tiny bits of matter through. We get a pattern like waves, like little marbles. How? How do pieces of matter create an interference pattern like a wave? It doesn't make sense. But physicists are clever. They thought maybe those little balls are bouncing off each other and creating that pattern. So they decide to shoot electrons through one at a time. There is no way they can interfere with each other. But after an hour of this, the same interference pattern is seen to emerge. The conclusion is inescapable. The single electron leaves as a particle, becomes a wave of potentials, goes through both slits, and interferes with itself. to hit the wall like a pop. But mathematically, it's even stranger. It goes through both slits and it goes through neither. And it goes through just one and it goes through just the other. All these possibilities are in superposition with each other. But physicists were completely baffled by this. So they decided to peek and see which slit actually goes through. They put a measuring device by one slit to see which one it went through and let it fly. But the quantum world is far more mysterious than they could have imagined. When they observed, the electron went back to behaving like a little marble. It produced a pattern of two bands, not an interference pattern of many. The very act of measuring or observing which slit it went through meant it only went through one, not both. The electron decided to act differently. As though it was aware it was being watched. It was here that physicists stepped forever into the strange, never world of quantum events. What is matter? Pulse or waves? And waves of what? And what does an observer have to do with any of this? The observer collapsed the wave function simply by himself.
So I was talking about light, which light has no weight, has no matter. It's just pure energy. It turns out electrons, which do have weight, how much they weigh, they do this too. And this, by the way, this is all physics, faith in physics, right? I'm not talking about faith, I'm talking about physics. Not my saying faith to believe the experiments. But they've reproduced it so many times that their faith that this is right has gone to no, this is what this world's made of. And this is what it does at the basic building block. One, I think it was a Christian author, might have been, I don't know, but said that pretty much everything we experience physically in this world, light hitting my eyes, and stuff like that,
Comes down to, oh, that's back on again. Comes down to a photon, which are these little things that go through, or an electron, which determines all the chemistry, or the interaction between the two. That's basically the whole physical world is made up of either something we experience with a photon, or with an electron, or interaction between the two. And these, so our reality is made up of these really mysterious things. And what seemed crazy to me in the Bible didn't seem as crazy to me as I was learning from physicists about what's real. So I'm going to leave it there. Hopefully that's a good tease. We're going to learn a little bit more next time. I'm going to refresh this with you because so another author I read said, if someone says they understand quantum physics, they don't understand quantum physics. Right? We can't, and I would say the same about the Bible. Beware of anyone who says, oh, they've got it all figured out. God's ways are not our ways. God is infinite or finite. And so I think there's things we can figure out, at least for us, but there's got to be this humility. And so, anyway, I'm about to say, who understands quantum? Because this is kind of quantum physics stuff. So I'm not going to say who feels like they understand what it's really saying, but you understand what I'm trying to describe. Raise your hand if it's like, I don't understand what you're describing. I have no idea how it could work that way. So that gives me a sense of there's a bunch, and it's very normal. When I teach this in class, what I'll do is I'll teach some of this, and then I'll go, hey, you three go talk about what I just said. And often you can teach each other, no, here's what he's saying. But because we're doing this pretty quickly here, not at the speed of light, but pretty fast.
So we obviously don't know how it is. Does anyone say later why? it doesn't, does it serve a purpose to have this duality? Is there some end result that needs to be able to do both things?
It's a great question. And there's a show I watch that always gives me a brain cramp on PBS called Closer to Truth. And it's a guy that's trying to discover the latest in physics that we're learning, the latest in theology, and the latest in philosophy. And so those are the kind of philosophy or theology kinds of questions. And there's just people all over the map about it. It means nothing. Nothing means anything. There is no meaning. Right? So a true atheist philosopher would go, yeah, no, it just is. But then there's other people, either theologically or philosophically, it means something. We're trying to figure out what's the purpose, why. But no, there's not clear. What we do know is that this happens. And I came from a world with Doyle where we could figure out materials and we could figure out how to hold things and say, yeah, we've got it covered. When you go to the underpinnings, it's like, I was like, I don't understand squat. And statistically, so individually, it's like, I have no idea how the world works. But statistically, I can tell you what it's going to be. When you give me a million or a billion or a trillion of these things, then we can work with them because there's order when you have gazillions of them. But when you just have one particle, it's really bizarre. Such that a mountain could jump into the sea without breaking any laws of physics. It's just that every one of those tiny little particles would have to do it at the same time. But it doesn't break any laws of physics for a particle to exist here and then all of a sudden exist here. And it didn't travel from there to there. It just, here I am. Next time I look forward to it, oh, here I am. They all did that at once. But it could happen. So you're saying there's a chance. Some of you won't get that. Some of you won't. Okay, that's enough for now. I'm happy to answer any questions afterward, but I'm going to speak about more of, so I basically said there's 5 things about light. One, it's got this dual nature. Time has no meaning for light, and it seems to know when we're watching it. And I'm skipping one of them right now. But next time we're going to talk about, I'm going to try to help you see that it can predict whether we're going to watch it in Acts 40. So anyway, give a great 4th. I hope you sleep well tonight. If you're really curious, go check out some Dr. Quantum stuff because he describes some other really weird things too. So, great, thank you all. God, I hope you do your magic.
Thank you, Roger. Catching questions now.